Hi everybody, here is your video on complex numbers for the snow day. So we have talked about imaginary numbers and they've come up whenever we've done the quadratic formula, whenever we were solving quadratics and finding the x-intercepts. And the first time in our class they came up is whenever we did the quadratic formula, and under our square root we got a negative number here. And before we know, said you can't do the square root of a negative, but we will talk about the history of I next time I see you. But mathematicians, it took a long time, but they finally came up with this definition here. Square root of negative 1 is I. So this is stuff we've talked about before. And we've used the word mainly imaginary number before. And I is the imaginary part here. But there's also this phrase complex number. And what a complex number is a number that is made up of a real part and an imaginary part. And the form of a complex number is a plus bi, where a is the real part and the b, or bi, is the imaginary part. So there's all kinds of complex numbers that you can have. For example, if I have 2 minus 7i, then your real is 2, and your imaginary is negative 7. If I have negative 3 plus 8i, your real part's negative 3, your imaginary is 8. So that's pretty self-explanatory. The imaginary part's with the I, the real part is not with the I. But what if I have something like this? The question is this a complex number or is it just an imaginary number? And if you say that it's just an imaginary number because it just has an imaginary part, what I would argue is, what if it was written like this with an imaginary 0 in front? Then the real part is 0 and it's still a complex number. What if I said 7? Is that a complex number? And you might say, no, that's just a real number because there's just a 7. But then what if you wrote it like this and you forced it and then it looked like a complex number? Then the imaginary part would be the 0. So then you might be wondering, okay, so why haven't we always called numbers like this complex numbers? And that's because you're too young to know what a complex number really was, I guess. But all numbers are complex numbers. Even numbers that you've seen ever since you could count, those can be considered complex numbers. Now, what some mathematicians did is to distinguish this from other ones that look like this, they would call this a pure imaginary number, just to let people know, like, it really only has an actual and imaginary part. That 0 doesn't really make it different. So this is a pure imaginary number. These are actual full complex numbers. And this would be a pure real number then. But they are all complex numbers. And actually, if you look at the set of all complex numbers, so if you go up in math in college, the higher up you go, you talk about set theory. And if I have the set of all complex numbers here, this box represents every complex number in the world. Within the set of complex numbers are your real numbers. And within the set of complex numbers are the pure imaginary numbers. They both are part of the complex number system. Okay? So another thing that we are going to talk about, I'm going to set it up now and we're really going to talk about it more in class, is powers of I. So we already know that I is equal to the square root of negative 1. And the square root of negative 1 is just I. But you can actually do powers of I just like you do powers of any number, like 5 squared, 8 to the 6th. So you can raise I to the 2nd power. And if I do that, then that is the same as I times I. Well, each I is equal to the square root of negative 1. And you want to think about something like this. The square root of 5 times the square root of 5 is just 5. The square roots cancel. The square root of negative 1 times the square root of negative 1 is just negative 1. It cancels. So let's keep going, and I want you to be on the lookout for patterns here. I cubed. We want to rewrite this in terms of lower powers of I. So what if I did I times I squared? Well, I know that I'm going to leave it just as I, and I know that I squared is -1, so I times -1 is -I. Let's keep going. I to the fourth. I to the fourth, let's write it as I squared times I squared. Those are equivalent. I squared is equal to -1 times I squared is equal to -1. -1 times -1 is 1. I to the fifth. How about we write I to the fifth as I to the fourth, because I to the fourth is the nicest one, times I. Well, I to the fourth is 1. I is just I. Holy moly, I'm back where I started. Look at that. Now let's see if this continues. I to the sixth. Okay, let's do I to the fourth times I to the second. I to the fourth is 1. I to the second is -1. 1 times -1 is -1. Woo, there we go. Let's actually do 2 more, and then in class we're going to finish up. I to the seventh is I to the fourth times I to the third. I to the fourth is 1. I to the third was -I. I'm back at -I. One more, let's see if we get the same thing. I to the eighth is I to the fourth times I to the fourth. I to the fourth is 1 times 1 is 1. Check it out. It's repeating again. It's cycling. So what I want you to do is make note of that cycles. And in class, our goal is to find really high powers of I, like I to the 73rd. And I don't really feel like continuing this forever and doing I to the 9th, I to the 10th, I to the 11th. I want to come up with a pattern or a rule that would allow me to find I to the 73rd in like a minute without doing too much work. So take a second and think about that, and we will discuss in class. So a couple of you have asked before, how can I plot an imaginary number, or what we're now going to call a complex number? And you can't plot it on the Cartesian plane, which is what you're used to. The Cartesian plane is just very normal XY. The Cartesian plane is often credited to a mathematician and philosopher called René Descartes. But this plane, like I said, only works for the real numbers. It's obviously not going to work for a complex number. So after hundreds and hundreds of years of struggling and arguing over it, and at first thinking it was useless and then deciding that it actually had some use, mathematicians came up with a complex plane. And a complex plane has a real axis and an imaginary axis. So this one is your imaginary axis, and what was your x-axis is your real axis. So we're going to plot a couple of these. And actually in college, if you take a class called complex variables, you'll do a ton of plotting on the imaginary plane. And it's a good time. So if you are plotting 2, 4 back in the day, you would just say, all right, 2, 4, easy peasy. What if I had 2 plus 4i, which is the equivalent of 2, 4? So you would go, this is your real part, this is your imaginary part, and I would go 2 on my real, is that 4? Yeah, 4 on my imaginary, and you're good to go. Now in math, the distance from the origin to the complex number is called z, and again, if you take upper level math, you'll talk all about z and its uses, but just as like a little preview here, that is called z, the modulo of the complex number. Let me do like 2 more here because this is really self-explanatory. If I had -3, -1, -3, -1, whoa, 1, 2, 3, -1, that would have been plotted there. If I had -3 minus I, which is the equivalent of that ordered pair, it'd be -3 on my real, -1 on my imaginary. And there would be the distance to the origin. And if I had like -1, 2, -1, 2 is here. And -1 plus 2i would be -1 plus 2i. So there's your complex plane. And you can plot all kinds of complex numbers on it. Again, real is horizontal, imaginary is vertical. The last thing I want to talk to you about are operations on complex numbers. This is going to be just like combining like terms with variables, which you did for many, many years here. The only difference is there's going to be an I instead of an X here. As long as you keep this in mind, you'll be good to go. When you do operations on complex numbers, you combine the real parts with the real parts, and the imaginary parts with the imaginary parts. So we're going to consider these two complex numbers, -3 plus 6i and 4 minus 8i. So the real parts are the -3 and the 4, and the imaginary parts are the 6 with the -8. Now, if I add them, I really don't need the parentheses. There's nothing to distribute. So you're just going to combine the reals. So it'd be I, that's your new real part, with the imaginaries, 6 minus 8i, -2i. So it's really just like combining like terms. There's just an I there. 1 minus 2i. If I'm subtracting, the negative is important, just as it always has been whenever we combine like terms. So I'm going to distribute the negative. So my real parts are -3, -4. My imaginary parts are the 6i and the 8i. And my new real part is -7 this time. And my new imaginary part is 14i this time. So it does make a big difference if you add or subtract. Now the multiplying. This is the only one where there's one little difference here. So if this was just an x, you would FOIL and you'd end up with an x squared, and it would actually be a quadratic. And a similar thing will happen here. It's just going to be an I squared, and then you can do one more thing. So -3 times 4 will be -12. -3 times -8i will be positive 24i. 6i times 4 will be 24i. And here's the only difference. 6i times -8i is negative 48i squared. Now we do not want to leave our answer like this. This is very unsimplified. So let's just start by combining our two imaginary parts. That would be 48i. Now -48i squared. I'm not going to keep it as I squared because I squared is equal to -1. If you look at your powers of I chart, then you'll see that I squared is -1. And then this actually turns into -48 times -1 is positive 48. So this turns into a real part. So then I have two real parts I can combine. -12 plus 48, that'd be 36 plus 48i, and there's your final answer. Now, once you get good at this, you might not need all 4 of these steps, but whenever you're first learning, it might be helpful to do that. So here are your 2 U-tries. I want you to do the same exact thing we just did with these 2 numbers and with these 2 complex numbers. So you can keep them in the 3 columns if it's going to help you organize it. And in class, we will talk about the history of I and about the powers of I more and do dividing. I'll save dividing for class. See you later. Enjoy your snow day.